Hello, my name is Steve. I'm with the Science Pastor Ministry, and today we'll be talking about speciation and why there is no proof supporting the concept of evolution actually being true. This video is called Speciation Proves Evolution. It's magic! Proponents of evolution claim there's an overwhelming amount of evidence proving evolution is real. When asked to produce that evidence, most often the first thing they'll point to is speciation. In simplistic terms, they'll say, look at that animal. Let's say it's a salamander. Look at that salamander. Its ancestors were all gray. Now it's a new species. It has spots. The salamander has changed. It can no longer breed with its ancestral population. That's evolution. Well, yes, the salamander has changed, but what is it? It's still a salamander. Then they'll say, well, with enough changes, it'll become something else. However, that step has never been observed nor proven to be true. The opposite is what is actually observed. Salamanders always reproduce salamanders. So let's find out what's happening. The problem in talking with evolution proponents is that the definition of the word evolution changes, sometimes right in the middle of a sentence, and a lot of necessary facts are ignored. So let's dig into the details. First, what is speciation? Well, the official definition, I'm getting this from the Encyclopedia Britannica, is the formation of new and distinct species. Well, that's really not much help. So, what is a species? The Encyclopedia Britannica defines a species as related organisms that share common characteristics and are capable of interbreeding. In the category of newts and salamanders, for example, there are 760 species, all of which look a little different, and none of which can interbreed with each other. So we have many different species of salamanders. Okay, now let's define evolution. The Merriam-Webster dictionary definition is descent with modification from pre-existing species. Let's go to another one. We're going to go to the Live Science website. It defines evolution as the process by which organisms change over time as a result of changes in heritable physical or behavioral traits. These are very broad definitions that include practically everything. They make it easy to prove evolution. If something changes in a way that those changes are passed on to the next generation, that's evolution. But does this definition represent what is commonly intended when the word evolution is used? Not really. It's much too generic, and that's a big problem. Evolution claims more than simply inherited changes. It claims that those inherited changes result in new, unique forms of organisms that have capabilities not seen in any previous organism. For example, fish. Fish become amphibians, gaining lungs and the ability to walk on land, among many other changes that are required. But fish have very different muscle and bone structures than land animals. For example, fins are not weight-bearing. They are attached to soft tissue. To walk on land requires new structures that can support the weight of the animal, such as legs connected to hips and shoulders, components that do not exist in fish. This means that additional information needs to be added to the genome, specifying all the changes needed for adding hips and shoulders. This is called specified complexity. Okay, what is that? Nature can produce complex structures, for example, snowflakes. But without a designer, the complexity is still random. Hips and shoulders are very complex structures, in particular on the molecular level. They must be made correctly and in the same way every time. That means their complexity must be specified. Unlike snowflakes that are all different, they have a specified design so they can accomplish a very specific purpose, walking on land in this example. Variation in the structure of hips and shoulders would be harmful. For example, in humans, Dysplasia is caused by a mutation in one copy of the UFSP2 gene. It usually causes severe, progressive, degenerative, and painful osteoarthritis of the hip joint, beginning in early adulthood and sometimes even beginning in infancy. A small change in the specification results in degeneration and reduced function. That's not good. The information that specifies hips needs to be correct, or there are problems. And this is called specified complexity. The hip must have a specific structure, and that means its design must be specified. And that's why, for example, all humans have the same hip structure. It is specified in our genetic information, and when something goes wrong in that genetic information, when something changes, our hips do not work the way they're supposed to. What evolution requires is that new, novel, functional specified complexity comes into existence, somehow, to produce a new organism that would be classified not just as a new species, but as being in a different genus, family, or order. Structures that never existed previously, as well as a system that reliably produces those structures, needs to come from somewhere. There is no evidence that there is any mechanism, including evolution, that is capable of adding new specified complexity to an organism. Instead, the evidence, such as the Cambrian explosion, shows us that specified complexity was designed into organisms from the beginning. So now, let's get back to speciation. What we see in speciation is variations of what already exists, or variations caused by broken genetic information. We do not see novel specified complexity. The problem with speciation as a proof of evolution is in how the word evolution is used. In 1960, Dr. Gerald Kirkut, he's a noted British zoologist and physiologist, he defined the two very different ways the word evolution is used. This is important. Here's what he wrote. There is a theory which states that many living animals can be observed over the course of time to undergo changes so that new species are formed. This can be called the special theory of evolution and can be demonstrated in certain cases by experiments. On the other hand, there is the theory that all living forms in the world have arisen from a single source, which itself came from an inorganic form. This theory can be called the general theory of evolution, and the evidence that supports it is not sufficiently strong to allow us to consider it as anything more than a working hypothesis. So we see that speciation, the development of a new species, is called the special theory of evolution. It shows change, but it shows us nothing about how life got from a single cell organism to all the different forms of life we see today. However, when the word evolution is used, it is most often referring to something greater than simply speciation. As Kirkut states, all life arising from a single source. This requires evolution to be capable of adding new specified complexity, or what is called, but inaccurately referred to, as adding new information to the genome. This has never been observed, nor is there any evidence that it has ever happened. What advocates of evolution are doing in using the same word to describe two different processes, yes, evolution involves inherited change, and we see that in speciation, but that's a very broad definition. As we get more precise, evolution, life coming from a single source, requires the development of new specified complexity. That step has never been shown to happen. The step from speciation to descent from a common ancestor has no basis in real science. What is observed is that specified complexity requires an intelligence to do the specifying. For there to be new structures, such as hips and shoulders, and they are very complex, requires that there be a designer who specified what those hips and shoulders would be like. A scientific proof cannot simply gloss over such a significant step, such as the addition of novel specified complexity. Speciation is very limited in what it can accomplish. To demonstrate that the general theory of evolution is true requires proving each step in the process. Nothing can be glossed over, especially a major step as significant as novel specified complexity. In my high school, my sophomore math teacher marked an algebra proof wrong if I did not show every step in the proof, even if I got the right answer. The proof of evolution fails that very simple high school criteria. The proof of evolution ignores the step from species to a new genus or family and assumes it just happens. That new specified complexity arises simply because, well, things change. That's not science. That's magic. And we don't believe in magic.